It is September 17th, 2015. I am here with presenter Ryan Faerman, who will be presenting on acceptance testing in Go. Thanks for coming out, Ryan.
Hey everyone, my name is Ryan Faerman. I'm a software engineer at Ultimate Software. We use Go a lot in all the things we do. Some of my team actually came out tonight. Thanks everybody. So before we start, a little bit about me. Hi, John. I've been an engineer for about 11 years. I used Go for about 2 or so. Before that, Ruby, PHP, a whole bunch of other things. I really like Go, some of the things you can do, some of the interesting challenges that using Go as a static language has. And one of the things that intrigued me a lot is acceptance testing in Go. So what are we going to talk about? Why do we test it all? I hope everyone is testing. If you're not, I hope this is just a quick primer. I want to make sure we all have a certain baseline understanding of what testing is, the different types of testing available. And then since the folks will talk what are acceptance tests in the framework of this talk. And since most of the testing that I deal with has to do with backend services, and I think Go really excels at that, that's the primary focus here. Now, there's also another next topic is why not use something like Ruby and RSpec? Fantastic testing framework. Why don't we use that? Then what does acceptance testing Go even look like? Right? How would you even set something like this up? And then ultimately, how can we make this better? So I'll show you some examples of how we can do acceptance testing and a couple things that I've come up with to help make it even better. So let's get started. So why do we test it all? So to paraphrase Uncle Bob, and if you haven't heard of him, look him up, fantastic resource about architecture, design, almost everything in the software space, and doing it for a long time. He says that bad code slows us down. And the key to cleaning bad code is to have a test suite that you can trust with your life, because you won't be afraid to clean the code. That's what our tests do for us. And the tests enable the team to go fast and for the application to stay healthy, which is ultimately what we want. We don't want to have a bad application, we won't have jobs otherwise. This mostly comes from an article called Test First. There's links here. You'll be able to see all of this. I guess we can put links to it all on GitHub, so you'll be able to take a look. So testing is part of our code. That's something I thoroughly believe. Testing isn't an afterthought, right? Our craft, at least I like to think of our craft, as computer science. We're not computer magic. And one of the key tenets of computer science is repeatability, right? The scientific methods. Other people should be able to repeat the same tests, the same things, and get the same result every time. Tests help give us that. Nice little go for there. So one thing is to note, tests are not about fear. They're not about my stuff might break, someone else might break my code, what if I mess up in the future? It's about confidence. It's all about confidence. You should never, ever be afraid of your code, and tests give us that capability. And it enables us to say, this code not only works now, it works in the future, it works when we make changes, it works when we refactor. We have a very high degree of confidence that our code works exactly as we expect because we have a good test suite. And there's all different types of tests. Right? And this is a very heated subject for a lot of people. You have unit tests, which test a unit of code, but that term unit is not really very well defined, so you can go back and forth on what that means. You have integration tests, which is another type of testing. Again, it's not thoroughly defined exactly what an integration, what are you integrating with? Google actually got tired of using these loaded words like unit test, integration test. Instead they call them small, medium, large, based on some metrics. And there's even whole schools of thought, black box, white box, mocking, not mocking. There's all different styles. And then ultimately we have acceptance tests. And I group these separately because at the end of the day, it makes sure that we get paid. So what are acceptance tests? According to Wikipedia, there's this long thing, feel free to read it, ISQTB, International Software Quality something something. Some long acronym in order that knows what it means. So formal testing, something wrong. What does this really mean? What is acceptance testing really? In the real world, acceptance testing is how do we make sure our acceptance criteria have been met? And these are usually defined by our customers, by the people using our application. What should they be able to do? What should they not be able to do? This may not be every edge case, but it makes sure that we meet the needs of our customer. Now, in the agile development world, which is a big methodology, these things are your user stories. They're things as a user, I should be able to do something, I should not be able to do something. When this occurs, I should receive this. If you've done Agile, you're very comfortable with this. They have a nice acronym, ISBAT, ISBAT, which just is because it's long enough to type. So one thing to note about acceptance tests is that these are generally fairly slow, right? They test from the outside. They're not allowed to go look at the underlying layer of anything, database, whatever you're using, they're not allowed to look at it because your users can't look at it, so why can your tests? They go after over real network connections, part of the reason for their slowness. They run on real hardware with real collaborators, and as a result of all of this, you probably won't be running these on every single code change. You might have CI or continuous integration that's going to do it, and maybe you will want to run it every, but not so much because they're slow. So why not use something like Ruby and RSpec? So a lot of people use build scripts in Go, whether it's a shell script or it's makefile, something like that. Plenty of people use rake files. On our team at Ultimate Software, we use rake files. We find they're very flexible. And we're already using Ruby as a result. It's a fantastic language. I like Ruby a lot, but it's designed for developer happiness. And as a result, different things make different people happy. So it's a very, very, very flexible language with a lot of magic behind it. And RSpec is just a tool, a framework that gives you everything you need to do your testing. Gives you expectations, gives you matchers, mocks and stubbing, lifecycle hooks, this entire DSL around doing testing. There are a lot of other frameworks. This is the one that I like the most, and it's not bashing on it, it's just I happen to like it. So what does an RSpec test look like? If you're not familiar with Ruby, this might look a little strange, but you should be able to read it. The user story for this would be, as a user, I should be able to visit health check and get a response with status code 200 and body okay. But that's a fairly reasonable user story. It's fairly fleshed out. It's pretty straightforward. You're just describing your health check. You have a request that you're testing a subject, testing a response 200, testing body okay. It's exactly what our user story is. So now we know when we ship this, it's clearly going to do exactly what we say it does. We can run this as many times as we want. There's a lot of Ruby magic behind the scenes. And it's very, very easy to get caught up in the Ruby magic to make these things a little more flexible. So this is one that's just the beginning. So this one actually is a whole bunch of tests. It looks like one, but it's a whole bunch. And there's a little bit of Ruby metaprogramming at the bottom there. If you haven't seen Ruby, the part of the metaprogramming is the send. And this is just scraping the surface of metaprogramming. And you can get really caught up in this. There are people who love metaprogramming, people who hate it. At the end of the day, it's magic. And the chances are, even if you're not doing this, something behind the scenes is doing this. And to try to trace this down is really, really, really hard. No full experience. And Ruby is great. I like it a lot. But have you ever heard something called metaprogramming? Yeah, you write your programs to write programs that write programs to alter at runtime. You can't trace anything out. Can't debug anything. It's very difficult to trace. What about monkey patching? Funny name. But that's the same thing. Things alter at runtime. You're modifying classes as they're being created in memory. Something to be a little wary of. Method missing, object sent, all these things that Ruby gives us that gives it a lot of power are things that, especially if you're not used to Ruby, can give you a big headache. Right? It's going to be a hard time to trace these things down, understand what it's doing. It's not as obvious in some ways as Go. And if you're a Rubyist, not every Rubyist has touched this. This is something that only certain types of people actually go in and start doing. Right? So if you're not, this doesn't make much sense to a lot of people. It's very magical. And the important thing to know about Ruby, it has no formal spec. The core developers on the Ruby team developing the mainline language actively are against testing their code. They do not have a formal spec. They've rejected every attempt. In fact, they have regressions as a result. It's kind of interesting. But again, it's because of developer happiness is what they're optimizing. They don't really care about those things. So let's remember some things that are important here. Testing is part of our code. It's our domain. In my opinion, it's our domain. Testing is our domain. It's not someone else's job. And we're used to, as Gophers, we're used to things like simplicity and clarity over magic, over being clever, right? We want to see what things are doing very clearly. And a lot of the things that Ruby provides may not be something that we need. So what would acceptance testing Go even look like, right? How would you do all this magic in a static language? Turns out it doesn't require very much magic. So this is a little bit more verbose, and it looks pretty similar, right? There's a flag at the top called acceptance test, just a helper to turn it on and off on demand. You do a request, we have to close our body, because if you don't, your Go routines go insane and your application will crash. Always close your body. We've had a lot of bugs as a result of not closing your body. And we have a little expectation library to go ahead and make sure the status code's okay, and that the status code's 200, and the body's okay. So this does the same thing. This is the exact same thing as the Ruby code. I don't think this is significantly more difficult to read, but this doesn't have any magic behind it, and I'm not a huge fan of magic. So what is that little acceptance is helping you solve? Again, no magic at all. It's just saying if it's a short test, using Google's parlance in a testing package, it just disables all of these. They're slow, you want a test to go fast, you turn on short, all the longer tests stop. And also, if you don't have the host defined, if you don't know where to go talk to if you're testing from the outside, turn off, test fails, right? And there's two ways to run our tests here. The short, we'll go ahead and skip all the acceptance tests, you don't have to worry about it, those go very, very quickly. And then if you supply your target host, it'll actually start doing all this acceptance testing, on top of doing your other types of testing. So it's very comprehensive. So we're already productive with almost nothing, right? The three things we need, which are something to make requests, something to run the tests, and something to give us some sort of output, are already in Go. They're part of the standard library. There's plenty of little helpers and functions out there. If you like the RSpec style, there's packages and frameworks for that. And we haven't really given much up in the way of readability, in my opinion. But it's not as good as it could be, right? Those tests can get just as easily out of hand, right, as Ruby. You can write Perl in any language, as the saying goes, right? So in the same way, our tests can be inscrutable. You can't tell what they're doing. And that just requires discipline, but there's ways we can do to make it better. And we already know how to do that. In our everyday lives as Gophers, as a Go developer, you know how to keep your code readable, how to document things, right? And by writing your tests in Go, you actually are honing that edge that much more, right? You're practicing these skills. And we can keep using the same tools we've been using for all of our code, packages, organizing things, interfaces. We can use all of that here as well, right? There's nothing special. But how can we make this better? So one downside of this, and this applies to the Ruby side also, you have to have a compiled version of this running somewhere. You have to have a host to talk to, whether your local machine or an instance out in the wild. And it's very, very easy to forget to recompile. I do it all the time. I forget to recompile. I know this should work. Why is the same bug not being fixed? Well, oops, let's shut it down and recompile, and now it suddenly gets all fixed. And if you're running in CI, you may not have the capability of running a binary locally. How do you deal with that? So chances are, if you're using some sort of cloud, you have to spin up an instance of not just the code, but all of its dependencies, the database, a queue server, whatever it is. You have to spin them all up, wait till they're all up, could take who knows how long. Start talking to them, do your tests, and tear it all down. And if you don't tear it down, your product manager or your accountant will be very mad at you, because those things get very expensive, especially if you're running these things that on check-in. You know, you can have lots and lots of stuff just sitting there, right? Sucking up resources, sucking up money. But what if, right, in an ideal acceptance testing world, our application was built for us automatically. Never have to worry about being out of date, right? It gets shut down and cleaned up as needed. It's tested the exact same way locally as remote, right? You don't have to do anything special. The less differentiation we have between local and remote, and local and production, local and staging, whatever it is, the easier it is going to be to debug information, to get your deployment scripts working correctly. The closer they are together, you're going to have a better time. Now, this all is very possible and very straightforward to do. No magic. Provided there's an excellent resource called the 12-factor app. It's a great guideline for creating applications going to deploy to the cloud and everything like that. They have a section called on the configuration, and it suggests strongly that your configuration should reside in the environment. Right? It's not talking about things like routes from the Ruby world. That's your code. It's talking more about what database do I talk to, right? Where's my database? What are some settings? What are feature flags? Whatever these things are, if that's in your environment, it's very, very easy to go ahead and turn them on or off. You want to deploy somewhere else? Okay, cool. Spin up environment variable. You're good to go. Want to run in Docker? No problem. Want to run a VM or on physical hardware? It doesn't really matter, because you're not tied to, let's say, config files or other things you have to maintain. And you don't have to check into something like Git or whatever version control system I assume you're using just to make a configuration change. It's pretty easy. Change the environment variable, restart the app, it's got its new settings. So just this is what the 12-factor app actually says. Again, all handles, no code. That the config is very different from other things. It varies across employees, whereas things like routes, code doesn't really change across the board. You should be able to deploy that code the same way everywhere. So this is an acceptance test rewritten to use this ideal scenario. In this case, what I'm testing is the example Go thing that they talk about a lot, log, the out yet app. Basically says, is a certain version of Go out yet? So in this case, it just returns status code OK, so 200. So we've modified our user story a little bit to fit with, as a demonstration, to fit with what this application actually does. The only thing that's really changed here is the application host. That's generated at the start. And I purposely made it different so we can see what the difference is. But what has changed is absolutely everything else. So if you're not big into the Go testing area, there's a special function you can have called test main, which allows you to do complete suite setup and teardown. So it's setting up your database connection, whatever it is you have to do, set everything up, you can do that here. So this one actually does everything that we need it to do. It kills any previously running instances. If maybe you get a panic or something, it makes sure you don't have anything wrong left behind. It builds the application, again, aborting if there's a failure. It runs the application, waits for the application to start up. And since I'm mostly an API guy, it's going to go on a port. I know where it's going to be doing. So I can wait. And then it actually runs the test and tears everything down. So assuming your test, whether you pass or fail, it doesn't really matter. And that kill previous is going to make sure if we panic that we won't leave anything behind. It's important to note here, if you are doing test main stuff, you can't really defer and catch a panic and rescue from a panic inside of test main, because each one of your tests run in a Go routine. So that's a gotcha here. So just be aware of that. So what has changed absolutely everything else. This is example output. I hope that's big enough. I can show you a live demo of this afterwards. I just want to make sure that the demo gods don't come get me. So this is just a recording of it. You see, he actually builds it, logs it all out, starts the bit file, waits for it, runs all the tests and kills and cleans up everything. So you can see it's actually working. So it's doing exactly what our ideal scenario would be. And it's not just our app. There are techniques to do this using Docker for all of your backend services. A lot of the code that I have here was inspired by painless MongoDB testing with Docker and Golang. It's a fantastic post. It's very, very cool. And this compilation trick was pretty much taking that and instead of running MongoDB or something, just running our code instead. And you do all of your backend services this way, right? Provided you're able to run stuff in Docker and have containers, it sets up pretty quickly too, other than the very first time you pain that you feel the very first time it starts to get it running. After that, it's pretty quick. It sets up and tears down onto it. So not to go too far into it, but these four functions is all that it needs to do all of them, right? We have build, run, wait for reachable, and kill. That's it, right? No magic. So to look at the build a little bit, already showing out to go build. This could easily, if you're doing it for yourself, if you have some sort of rake file or something like that, call it to your rake file, call it to your rake release, whatever it is that you're doing, however you do your building, you can do it this way. And here, all we do is run it and wait for it blocking. We block, wait for it to compile. When it's done, we're good. If there's any errors, we can abort our suite. And then we run it. There's two key things here that are different than before. So the first you see is testing verbose flag. So if we're in verbose mode, I kind of like seeing what the application's doing if it's verbose. So I hook up the standard out, standard error from the actual application to my current one, so I can see everything that it's doing. And the second thing is command start. Before it was command run. They're very similar, but command start actually starts in a child process in the background, and it returns the command will return a process, so you actually can now manage and communicate with that process. And finally, wait for reachable. This is mostly just a wrapper around a NetUtil package from Camel Store. Pretty straightforward. It's mostly logging, and it makes it customizable with the timeout. I have it set to 5 seconds, but you can do whatever is reasonable for your application. And we just wait for it. Literally just pings every certain amount of time, waiting for the application to respond. And if it times out, it errors. Nice and simple. And finally, we kill everything. This kills the application if it can. Sometimes it can't. Every once in a while, it's something that it can't kill. So it logs when it can't kill it, so you can go kill it manually. It cleans up after itself, and it removes the actual binary that it built at the beginning. And I keep track of a PID file. In case there's a panic, I can clean it up next time. So this cleans up all of our build artifacts. And so what have we learned from this? So this whole thing. So we've learned that what we do is computer science, right? We're not doing computer art. I think that is something really important. We can't ever forget that what we need to do is repeatable, it's engineering, and we need to make sure that our system, when it goes out to our users, is exactly what they expect. And acceptance testing really gives us that. That testing is absolutely part of our domain, right? We can't push that off to the users to do. They're not going to have the knowledge to be able to test as completely, at least I hope, as completely as we do. They'll test in a different way, and they will find bugs that we never thought of. But we can do our best to make sure that we don't push out buggy software if we make sure to take that on ourselves. Even if we have dedicated QAs, we still should test it, at least casually. And something also part of this is you're going to be testing this because, again, acceptance tests are driven by users. The exact way you would physically go start the server, make a curl request, that is your test. And now you can do it a lot faster, and you can run your entire suite without having to forget about certain use cases. And we don't need to use another language to do our acceptance tests. I'm a big fan. In our domain, we should have one language. There's less context switching, there's less skills involved. You don't have to know as much about as many random things. You don't have to be a Rubyist and a Gopher in the case of using Ruby, or whatever framework you choose to use. If it's JavaScript, if it's, I don't care. You don't need to have experts for both of those things. You can focus. That's very important. And we can use Go itself. We can use a standard library to resolve some of these issues with our acceptance tests. It's very hard to do something like this in Ruby. I've tried. And to try doing a trial process and communicating with it, it's very easy to lose communication with it. And suddenly you have rogue processes going, you've lost control of. Ruby decides to compute the heat depth of the universe, whatever it does when it starts. If you've done anything with Ruby or Rails, you know you felt this pain before. And it just, I like testing this way. I think it's kind of nice to be able to understand exactly what everything's doing. We can auto-build our code and run all of our collaborators in the background as child processes and manage everything, just like we do with Go routines, just like we do with all of our processes we do. And then I think with a little bit of work, whether it's just straight up writing your own stuff, whether it's using something like Go Convey, you can make your tests almost as readable or as readable as Ruby and RSpec. Right? You don't need a custom DSL just to get testing. You don't need to learn a custom DSL just to get your testing. So that's pretty much what I've got. I can show you a live demo that's actually running. It's pretty much works exactly like what it says out of the box. If you have any questions at all about testing, Ruby, Go, I'm all ears. I can show it running. So go test short. Just do dash. And actually, it comes exactly. Ooh, no such host. Oh, they don't have internet connection. That's cool.
The demo gods.
Yeah, the demo gods. So I don't have internet connection. So the application couldn't really communicate to the outer world, but in the way that Albiet works, it actually just runs into Go routine and tries to talk to it. So our page will still load. So it works as far as we're concerned. That part works. Yeah. There's no test for if it actually gets a real answer. But it cleaned everything up. Oh, so in order to make sure that standard out really was writing, I made it say yo, yo, yo a whole bunch of times. So I could see that it was outputting something. And maybe this is the application saying it's logs. I don't know. It's starting up. Because one of the other things in the 12-factor app is to log to standard out, standard error. So I can actually see everything my application is doing from standard, same way as before. And that only works if I have verbose turned on. In fact, if I don't have verbose turned on, it's just going to sit there and just say, okay. Come on. There we go. You can see these are slower, but it took roughly the same amount of time. It took, whatever, 3.5 seconds. And most of that was waiting for the application to build. And then just to make sure that he actually waited for it to be reachable, I purposely, when the application started up, before it started the server, there's a sleep, a 2-second sleep, just so we can see that it's slow, right? Because if you don't wait for it to be reachable, it'll actually, the test running is faster than the application loading for the most part. So it'll just sit there trying to talk to everything will freak out. Nothing will work. Like my whole entire test suite's broken. No, it's not. You just have to wait. So with a little bit of work, you can take care of a lot of that. And like I said, if you're starting with a database or something, it might take a little bit longer, but that's pretty fast. Like 4 seconds to get an acceptance test, the entire environment. That's still pretty quick, right, as far as acceptance test goes. Ruby, probably in 4 seconds would just be getting out the door. So.
do you have like what's the biggest or most complex environment you've had to set up? You ever had to do a test like multiple Docker containers?
So acceptance testing in general, the most complex one had MySQL. It had a Redis server, so we work as a queue. It had the application itself. Then it was doing stuff with the file system, and that was one application. Another one actually was talking to a third-party server. It was talking to Zencoder. It was actually talking to Zencoder to send files to be encoded. And one of the ways you can make your application actually talk to that is, again, if you are getting your configuration from the environment, you can use HTTP test server to spin up a test server in the background, right, that you can communicate with, that responds the same way as Zencoder would, gives the same input to Zencoder would. You can even purposely make it slow down to go ahead and give you the throughput without really talking to the third party. But that still probably should be enabled and disabled with a flag, because at the end of the day, you're still going to want to really talk to these third parties. Because your test implementation, it's fine to work for your test implementation, you're not testing the real thing, right? You're just doing that to cut down on, in this case for Zencoder, encoding costs. Right? Why should you spend $1 every time you have to run a test? So this way, before you go to production, you can set a different environment variable. Instead of starting up a test server, you talk to the real Zencoder with a real file, and you can verify that its output is working. And when you're doing stuff like that, where it's tangible artifacts, there is going to have to be some hand checking as well. You want to make sure that it really is sitting inside of Zencoder. And if you want to go really down a rabbit hole, you can start using their API to see if it's there. But I think that's overkill. For most of what I've done with it, it's like, okay, cool, it encoded, I see the outputs, I can load it up. It doesn't look like total garbage. It's really hard to teach a machine to know if something encoded well. It's not worth the time. I'm not a video engineer. It looks good to me, it's good enough. So that's where most of the collaborators.
And when you do your tests, like, do you assert just the response code when you do APIs, or do you assert like the content?
It's a balance. I almost always will assert the status code. I think that's a really quick check. If that's not what I expect, chances are the rest of the test isn't working well. So it's a quick and dirty way. At least when I'm starting to write my test, I can say, cool, I got the response code I want. I can now write the rest of my test, because I do a lot of TDD. So that's a good starting point. From there, I will look at the body. And then depending how complex the body is, if it's a big JSON response, if it's small enough, I'll actually just do like a string match with variable interpolation and kind of just say, okay, cool, the stuff I expect is in here, and we're good to go. If it's a little more complicated than that, I don't like doing a lot of like mapping the string to interface to try to build something and do all these coercions to do testing. There's a very cool package called JSON, J-A-S-O-N, which is all about pun. Someone said, oh, we support JSON and XML now. But that's very cool. It lets you actually pull out different keys and paths to keys and then do assertions against that.
So how do you like integrate this into your test suite? Is it like a just go get it in a library and you call something, or you have your own test name function written?
There's a couple different ways. If you want to sort these out completely and completely turn off all acceptance testing, you could use a sub-package called acceptance or something like that, so you can explicitly say go test acceptance, right? That's very clear and obvious what it's doing. You could have a helper function that looks for certain environment variables. It's okay to use flags to do that. You can parse the flags, but the only issue with that is that if you add a flag that GoTest doesn't know about and nothing picks it up, it just flag parse kind of parse. So I don't know how to do this, and it just freaks out. So then you have to then add something that's just going to parse the flags to all of your tests, which is not ideal. I want to try to keep those things separate. So if you are going to do those sorts of things, where you do want to be able to have flags and command line parsing, I would make a sub-package. But it really is entirely up to you. And since it is spinning everything up on demand, you could just use the short flag to turn it on and off, right? Because you don't have to worry about the target nodes. You don't have to worry about, I've set it up somewhere else, then I can start talking to it, right? You don't ever have to supply that. It's kind of internal. And if you wanted to get a little bit more fancy, there's plenty of examples out there of how to pick an open port in your machine. I think HTTP test server does that, so you can look in the code to see that. So you can give it a completely random free port every time, so you don't have to really worry about it. And you just pay, because it's not short, you're going to pay that build cost for 7 seconds. Actually, it's longer in 1.5, which they're supposedly going to fix by 1.6. But a couple seconds overhead to get a really comprehensive test suite, to me, is a questions, concerns, comments? Cool.
Well, thank you very much, Ryan. That was very helpful.